This video is for the homework nice third question. And in the third question, we get a Poisson process with the normal distribution, and we have to prove or disprove that the probability the xt multiply the xt divided t minus lambda is in one probability. And first, since it is a Poisson process, so we can get the expansion and the variance from the Poisson process. It's easy. It can be get from the book. The expansion of the Poisson process is lambda t, and the process and the variance of the Poisson process is also lambda t. So this so then we find that we need to know how to prove the probability of xt divided t minus lambda is in probability, and we have to use the Chebyshev inequality. Since we easily find that this why will I choose use the Chebyshev inequality, because this equation is really like to use this inequality. And when I try to put this equation into the inequality, I find that I can get the result. So this is the reason I finally use it. And there is a key to solve it, because we know that the probability is equal to 1, which also means that there should be a probability of xt divided t minus lambda would be larger than some value larger than epsilon, and this probability should be 0, which is get from the 1 minus the Chebyshev inequality. And then we just expand the Chebyshev inequality, and since we know that it could be get the real Chebyshev quantity should be like the xt minus lambda multiplied t smaller than 1 epsilon, and we put we multiply two sides of t, and we can find it looks like the normal Chebyshev inequality. And the limitation when t close to infinity, lambda t divide square of t multiplied square of epsilon, which is 0 since t is close to infinity. And therefore finally we can get the limitation of t close to infinity. When t close to infinity, xt divided t equals to lambda in probability.